I'll tell you just a little bit more about my experience here. When I was in the Air Force, I designed and operated a fog dispersal system out at Fairchild Air Force Base, in which it was designed to get rid of fog so that the bombers and tankers could launch and recover. And that worked very successfully for about 15 or 20 years before the landing systems were able to allow the planes to come in at much lower visibility. They didn't need it anymore. But it was a very successful system right here at Spokane. Well, I thought I would share with you a little bit today. I've got about 20 minutes to present the information. I'm going to give you an opportunity to ask questions for about 10 minutes at the end. We go till 20 till?
Yeah, that works.
Okay. So
35.
Oh, okay. Well, I'll try to stop by 25 after then. At any rate, I want to tell you a little bit about global warming. Let me start. How should we do this? Just click it. Okay. This is a little exaggerated at the beginning, but it'll get your attention. Everybody's concerned about such things as the glaciers and ice sheets are disappearing. They're all melting, going to end up filling the ocean so it's deeper. And that higher ocean is liable to flood a lot of the cities around the low-lying areas of the continent, like New York City. Possibly cause polar bears to go extinct. At least that's the concern. Okay. And also possibly increase the frequency and the intensity of hurricanes and typhoons. And so we need to ask, is this really true? Is this likely what's going to happen? Is there evidence that it's really happening now? Or what will the future bring? If you hear the news events, every time there's a major storm, whether it's a drought, whether it's a snowstorm, whatever it is, it's always global warming these days. Now, they can't all be true, but it's a convenient way to be able to blame the problems with severe weather on a particular thing we think we understand. But there's still a lot of controversy among even the scientific community, not just the general community, but there are many scientists who still don't believe that global warming is actually occurring. Now, I'll give you the short answer here. As a Christian and a young earth creationist, I started studying this a number of years ago. About 20 years ago, I began to do research on this. And my final conclusion is global warming is occurring, but it's not very large, and we shouldn't be overly concerned about it. And most of it is naturally occurring in a cyclical form, and it's not due to our activities. Some of our activities do cause a little bit of global warming, but it's not a major amount. In fact, there's concern today by many in the scientific community that we may be heading back toward another ice age. It's starting to cool back down again. And even the conventional scientific community is finally recognizing that. So I think the idea of it being cyclical and a natural process of some kind is probably the best explanation. Now, let me give you a little bit of background to that. I started thinking about this, as I said, about 20 years ago. And so my first question was, is there evidence in the actual data that there is some global warming going on? And one of the basic principles that most scientists base the concern about global warming is that the measurement for carbon dioxide in the atmosphere is increasing. And that evidence comes from a place over in Mauna Loa on the big island of Hawaii. There's two mountains over there, volcanoes. One is Mauna Loa and Mauna Kea. The one on the far side there is Mauna Kea, where there's a bunch of telescopes for doing astronomical studies. And the one on the other side is Mauna Kea, and that's where there's a laboratory that was set up back in 1958 by the University of California at San Diego to start measuring the carbon dioxide concentration. And here, this next slide shows the actual measurements from 1958 up to about 2012. I haven't added the last few years to that. But you notice that the axis on the left here, the number down there is how much carbon dioxide is in the atmosphere. It's 320 parts per million. That means for every million, say, oxygen and nitrogen molecules, there is one molecule of carbon dioxide, 320 molecules for every million molecules of the other gases. Well, you notice that that's gone up by a significant amount, probably about 20% in the last 50 or 60 years. And so it's continuing to go up, and that's the basic concern that people have, because carbon dioxide in our understanding in the atmosphere, that's what causes the atmosphere to warm. In fact, if we didn't have any carbon dioxide in our atmosphere, the atmosphere would be, the temperature of our Earth would be much cooler than it is today. It's what keeps it warmer at night and at various times of the year. Go back, I didn't quite finish there. You also notice some little oscillations. The black line is kind of an average. Little red oscillations are annual, so that it varies from year to year. And it turns out that as plants in both the ocean and the forest die in the wintertime, they release carbon dioxide into the atmosphere, and that's where you see the high peaks of each of those lines. And in the spring and summer, when the plants in the ocean and in the forests are growing, it sucks carbon dioxide out of the atmosphere, and the carbon dioxide goes down. So it oscillates from winter to summer through that period. Okay. Well, my question then was, is there any evidence? There's no question about what the carbon dioxide concentration is going up. Now, we don't know why, we don't know where it's coming from, but if it is, which we have evidence for, what would effect be on the weather? And so I decided to do a study with my limited computer power. I don't have big Cray computers like many people in the government labs have, but I was able to have access to all the data that the government has. So I selected a small sample of data and decided to check 4 things. The first one I looked at was the temperature of the ocean. And I picked this particular site is a buoy that takes the measurements of temperature and wind and pressure, both in the air and under the ocean. And I was particularly interested in taking the data from that to see what the temperature of the ocean was doing, because it turns out the temperature of the ocean is most significant in terms of what the atmosphere is doing. It has much more energy in it, and carbon dioxide for that matter, than the atmosphere does. So if it's going up, it's going to affect the atmosphere greatly. So let's go check and see whether the temperature of the ocean appears to be warming. Next slide. So I picked a site. There's a bunch of these buoys that's been put out in the ocean, and they've been out there now about 40 years. There weren't any before about 40 years ago, but you can go and collect the data from that, and it's all on the internet. It's all on the internet if you know where to go, and you can download it and analyze it. I picked a spot here down in the Gulf of Alaska, and the reason I did that was if I had picked one up in the area up here, in the wintertime, it would be covered with ice, and the data wouldn't be any good. The whole buoy would have been frozen up. So I picked one down there, close to Alaska, and I picked one that had the longest record. And here's what the record looked like. This is the temperature in degrees centigrade. You need to learn how to read degrees centigrade. 0 degrees centigrade is the same as what in Fahrenheit?
32.
32 degrees Fahrenheit, that's right. Well, that would be down here. So this is warmer than freezing up here. And this is time starting about 1977 or 78, I believe. And this varies throughout the year, but you see there's a general upward trend. So we have actual data from the ocean for about 30 years where there's a slight increase in temperature. Okay, so that appears, yes, there does seem to be some warming. Next one. Well, another one is, have we had more hurricanes, or have they been more intense over the last years? And so I was able to get access to the data on the internet to look at that. The next slide shows this for the last 150 years or a little bit more. And now we didn't have satellites until about the last 30 years to do some of this data. And these are actually tropical storms that come into the southeastern United States and impact the Gulf of Mexico and along the East Coast. There's other places around the world we could look at, but this data is also available on the internet. Some of the data that starts back here is the observation. This is in terms of how many hurricanes occurred per year, and we know that because there was a lot of shipping. People that used to have sailing ships and steamships, they kept track of these hurricanes there because they didn't want to get hit by one of them. The last 30 years is satellite data, but you notice how variable it is. This is in terms of numbers of hurricanes per year since 1840. And again, there's an incline or an increase in the number of tropical storms. Now, a tropical storm is a storm that has this circular rotation. It's counterclockwise in the northern hemisphere, and it's below 39 miles per hour. As it gets over that, it's called a hurricane. So this is actually fewer. I mean, this is weaker storms than a hurricane, but the hurricane has to have an incipient tropical storm before you get a hurricane. So I decided to look at those. Well, you notice again, there is an increase. There is some problem with that data. You can't be absolutely convinced about it because some of the earlier ones were done by observation, not without, because you might have missed some. So there might have been some more down here than we would expect. So maybe that increase is not quite as great. But the evidence seems to be that there are more hurricanes today than it has in the past, or at least tropical storms. There's also evidence that they are stronger. Okay. A third one I looked at was the coverage of ice sheets up in the Arctic Ocean. And you see here, for example, two particular times, the ice in the Arctic covered in the summertime, it covered around to this kind of pink purplish line. And in 2001, in 2006, it only filled that much where the white area was. Well, I looked at more detail. The next slide shows the coverage of ice sheets ice shelves and sheets in the Arctic from 1975 to 2010. Well, and this is in terms of area in millions of square kilometers. That's kind of hard to get a grasp on. But the basic idea is there has been a decline in the coverage of the Arctic Ocean by ice. So that seems to be consistent. If the water is getting warmer, the ice is going to melt. Okay, next slide. The final one I looked at was global temperature. Now, we got weather stations all over the world, particularly in the northern hemisphere, and all that data is available. Now, I had to, on some of this data, I just had a very, very powerful laptop computer, but all that data just bogs my computer down. I brought it to its knees trying to analyze all this data. But this is what the temperature looks like from about 1880 up to about 2000. We don't have direct measurements of temperature before about 1880 because we only developed the thermometer in the late 1800s. So everything earlier than that is based on what are called proxies, other information that we know would change if the temperature increased or decreased. But you'll notice here, and this is a global mean temperature for the period from 1880 to 2006, and it's the deviation. This is not the actual temperature here. This is the difference between the temperature and a value in between from 1951 to about 1980, that average. Before that, the temperature was below that, and after that, the temperature is higher than that. And you notice here, as we approach the year 2000, that temperature has been increasing much greater than it is today. But there's than it had previously. However, there's a very important thing you need to notice here. From about 1880 up to about 1940, the temperature was increasing, but suddenly in 1940, right at the end of the Second World War, suddenly the temperature started to decrease until about 1970. When I went to graduate school, all my professors were concerned we were going to go into another ice age. And about 1970, which is when I started graduate school, suddenly the temperature started increasing again. Before that, one of my major professors was planning on doing a research project with the Air Force in which they would dump carbon black on the poles to try to melt the ice and warm up the Earth. I thought it was a crazy idea. But when this happened in 1970, they dropped the whole idea. And then when the temperature started going up, now we're concerned about the Earth is going to get too hot. Well, in about 2000, I don't show this data here, but it's leveling off, and now they're concerned it's going to go down again. And so now they're starting about carbon black on the polar regions on the ice again. So we keep chasing it, but we don't understand why it's happening. Okay, next slide. One of the reasons it may be happening, or why the temperature is increasing, this has independent of the carbon dioxide, the data includes the actual measurements of thermometers, but almost all of the thermometers have been placed for long periods for the last 75 or 100 years in places that the cities have grown up around them. This is a station in Marysville, California. And in here is a temperature measurement. It's one of those weather stations, and it has the temperature and humidity and the wind. But here it's right around a building, and here are all these air conditioning units. Here's concrete, here's cars, and you can imagine that it's much warmer now because of all that concrete and buildings and effect around it, and that's going to be affecting the temperature measurements. And there's no easy way to remove that from the temperatures. It's called the heat island effect. Around cities, the cities are hotter in the daytime and colder at night than it is out in the country. You may be aware of that effect. And there's no way to extract that from the actual data. So part of this global warming is actually in the data caused by sighting of the weather stations. Okay, next slide. Here's what the actual temperature looked like for the last 1,000 years. This goes all the way back to 1,000 years before today, or 1,000 years after Christ. And this is the estimated temperature in degrees centigrade again. Sorry, I'm a scientist. Up through today. And there was a period back around 1200 AD, about 800 years ago, in which there was a very warm period. The temperature was very warm, and then it cooled off down into what was called the Little Ice Age. So it wasn't a big ice age, it was a little ice age where the river, the rivers in Europe froze over, and all kinds of cold weather occurred for several hundred years, and then it started warming back up again, and we're in this period here where it's getting warm again. So here's some evidence that we got a cyclical heating and cooling. Okay, next one. Here's a suggestion or a theory that this various cyclical nature may be due to activity on the sun. We know that the number of sunspots on the sun change from year to year. The number of sunspots is reflective of how active the sun is. It tends to boil and then calm down and then boil again. Whenever it's very active, it has a lot of sunspots on it. Well, this is the solar activity measured by sunspot activity, and you notice it goes up and then declines and goes back up again. That's about the same time we saw the effect of temperature from about 1940 to 1970. And we also noticed that the Arctic air temperature is in a similar shape. So we may be getting a hint here that this may have something to do with activity of the sun. Next slide. Here's a picture of a sunspot. You've probably seen these. There's just all kinds of pictures of them. Associated with those sunspots is where big flares come out of the sun, and it throws out electromagnetic field as far as the Earth and beyond. So it incorporates the Earth in that electromagnetic activity. We're actually in the field of the sun. Next picture. Here is the observation of solar sunspots over the last 400 years, all the way back to around 1650 to about 1700. There was something, a real extreme minimum of sunspots. And then as we go here, they vary, but you notice they have a cyclical nature. About every 11 years, there's a peak and then a valley. And that's natural, but the peaks and valleys actually go up and down. And we're going into another major valley. We may be heading toward another minimum of sunspots, which may mean that we're heading toward much colder temperatures. Next. Okay, here's a theory that was put together by the Danish Astronomical Research Group. And here's a theory. It has to do with the active and inactive sun. They suggest that when the sun is inactive, the magnetic and electromagnetic field around the sun, see there's no sunspots on it, when it's around the sun, the Earth is exposed to more cosmic radiation coming from outer space. If the sun is very active, it puts out a bigger field, and it protects the Earth, and it keeps cosmic radiation coming from all directions. They theorize that the cosmic radiation produces more particles or nuclei for cloud droplets to form on, and there are more clouds on the Earth when the sun is inactive, and that causes more reflection of solar radiation and causes the Earth to be cooler. Next one. When the sun is very active with lots of sunspots, it extends its electromagnetic field out beyond the Earth and protects the Earth from these cosmic radiation coming in from space. producing fewer clouds and therefore a hot Earth. Now, there's been research going on for this for now 10 years by a fellow by the name of Jasper Kirby. He's a scientist at the CERN laboratory in Europe. It's actually in the Alps and the border between France and Italy. And he has a big cloud chamber, it's called, a gigantic cloud chamber in which he's exploring this theory to see if, in fact, cosmic radiation produces more particles which produce more clouds. And if you got more clouds, then it's going to keep the Earth cooler. Or if there's fewer particulates, you get more clouds, and it gets, if you have fewer clouds, then it gets hotter. So that's the theory that's probably one of the leading ideas today, what causes global warming and this fluctuation. Okay, I'll go on to the last one here. Okay, so here's the basic ideas I'm trying to present to you. Global warming, I believe, is occurring, not a great amount, and we don't need to worry about it running away and destroying the Earth. It does have an effect on weather. Most of the global warming is probably due to natural variation, and increased CO2 is related to that, but only in a very small way. There's also another thing we need to be aware of. The more CO2 we have in the atmosphere, the better it is for plants. You know, there are the actual farmers that when they're growing crops inside of hothouses, they actually release carbon dioxide into the hothouse to make the plants grow faster and to need less water. So actually, you know, plants are gobbling up the carbon dioxide. We eat the plants, and then we release carbon dioxide and are able to get oxygen. So there's a balance that God has built into our atmosphere. Well, the thing that's really interesting is there's so much conversation about trying to change the temperature that we got to stop it from getting too hot. And it may be in a few years we may think about how can we stop it from getting too cold. Our puny efforts as man to try to make a big change on the whole atmosphere and the ocean is so puny that it probably wouldn't be very effective anyway. So for the idea of cutting all of our industrial processes and ruining our economy for the very little effect that we're going to have probably is a waste of effort. Okay, I'm going to stop there and see if you got any questions. I'm sorry I had to rush so fast. This is normally an hour presentation. So, do you have any questions about global warming? I did that good a job? Oh, come on now. I know better than that. What did anything I said that you didn't understand or you don't agree with?
Question?
Yes.
So you believe that all this is happening in a cycle, global goal, right?
Yeah, I think there's a cyclical nature to it, yes.
But wouldn't it eventually reach equilibrium where it's like stay in the middle instead of going in cycles?
Well, the atmosphere in the ocean is a very turbulent system. It's kind of like if you go down to the river and you see these little eddies that form along the bank when the current's going down a river. These little eddies tend to be over where there's a lot of shear near the shore. And as they move around, they produce fluctuations in the flow of the water. That's actually why we have fluctuation, why we have storms that come through in our weather. The same thing happens in the sun. The sun has these periods in which there's large amounts of sunspots because it's a fluid that is flowing. It's electromagnetic fields surrounding the hot fluid in the sun. And this is like a pot that boils and fluctuates, but it never comes to a complete equilibrium. But it does have an interesting point related to the Genesis flood. If I had more time to talk to you about the Genesis flood, I believe that all this effect was caused by a major disruption of the earth, particularly the crust of the earth and part of the mantle. And there was a lot of volcanic activity. The continents were moving around very rapidly, tremendous flood destruction. But when that was all over, things began to calm down. For example, earthquakes and volcanoes. There was tremendously intense earthquakes and volcanoes during and immediately following the flood. But that process slowed down and has reached a equilibrium, sort of. It's approaching an equilibrium, but occasionally there's a fluctuation in the number of earthquakes and volcanoes. The same thing is true in terms of temperature because there's always a little bit of fluctuation. Nothing like what happened at the time of the flood. But today we're close to an equilibrium, but there's still some oscillations in it. So I don't think he'll ever reach a just smooth equilibrium. Other questions? That raised other questions for you? Comments? Tell me you don't agree with me. I can handle it. How many of you guys are going to go into science? Anybody interested? No? What science are you interested in?
Chemistry.
Chemistry. Oh, that's a good field. What about you?
I don't know. I kind of like all of them.
Like all of them? I'm what's called a meteorologist. That was my training, or an atmospheric scientist, actually. A physicist is somebody who studies all of science, not life sciences, but physical sciences, and he thinks he's an expert in everything. Well, my undergraduate degree was in physics, but my graduate work was in atmospheric science. So I can forecast the weather, and I can also do research on it. My specialty had to do with ice crystals, how they grow and how beautiful they are. And that's why I got involved in cloud seeding for the first 20 years of my career for the Air Force, getting rid of fog over here at Fairchild. Because what I was doing was releasing carbon dioxide into the atmosphere, believe it or not, propane, I'm sorry, releasing propane, which was very cold. It produced ice crystals, which grew in the atmosphere, fell out as snow on the ground, and left a big hole for airplanes to be able to land and take off. But my specialty was in ice crystals and cloud seeding. But then, toward the latter part of my career, I became a paleoclimatologist. Now, that built on all of the training I had before. Climatology is a study of the longer periods of weather. And paleo, does anybody know what paleo means? Okay, it means old climates. Now, the standard definition for a paleoclimatologist, which is what I am, the standard definition is I would study climates and weather millions and millions of years ago. I believe from reading scripture and the research I've done that the earth is only on the order of 6,000 to 10,000 years old. So, but I still call myself a paleoclimatologist in that I don't study climate today so much as what it was 4,000, 5,000, 6,000 years ago, closer to the flood. So I've done a lot of research on that kind of a climate. What happened during the flood? What happened right after the flood? So that's where most of my research was done. And the global warming thing kind of came in because it became such a controversial topic. Next week, President Obama and leaders from about 150 countries are meeting in Paris. Let's hope they don't get blown up. They're going to be talking about global warming, and they're talking about instituting much more stringent controls on our release of pollutants. And that's another thing that we need to deal with. As Christians, we need to be good stewards. But my personal philosophy toward this whole thing is to use it, but don't abuse it. In other words, God gave us the responsibility and the authority to use this world that we live in, but we shouldn't turn it into a trash heap. We shouldn't turn it into a dump. Now, the question is, how do you balance all that? Some people today want to return our world back to the way it was at the very beginning, even though they don't recognize or accept the idea that God created this world. They don't want any industry at all. They want it to be completely pure. And that's not really reasonable, particularly with the large number of people we have on the earth. So how do they solve that problem? They say we need to get rid of a lot of people. Don't even let them be born. So you can see how this gets into the morality of the whole issue. So it used to be a scientist was just a scientist. He didn't have to worry so much about the morality. But today, you got to deal with the morality of what Scripture says, as well as how we live. So don't think you can get away from it. You got to deal with it even as a scientist, Dave. Maybe specifically because you're a scientist. Okay. Any last comments or questions there? That should get you interested. If not, anything else?
My parents would love to talk to you. They're both meteorologists.
Oh, really? Where do they work?
My dad, he works at like the weather station.
Here in.
It's like the big white ball.
Oh yeah, he does the radar out there at Geiger
he
Field.
does, like the real kind of sciencey stuff, and then my mom is the one who does the things on TV.
Oh, she's a weather lady,
Yeah.
weather person, meteorologist.
Yeah, for crime.
Oh, okay. What's her name?
Michelle.
Michelle. I've been watching the TV, but I've been watching Crim. When did she, during the day or in the evening?
She's kind of like a fill-in. Like she doesn't do it regularly, but she is working on Thanksgiving. She's doing the morning show.
Oh, I'll keep an eye out for her. All right. Well, thank you. Yeah, it's a fun field. Really fun field.
Thank you very much.
Thank you.